Hey Skeeter Nation, today we are learning about discrete data. Now discrete means that the graphs will be disconnected. Now this is really cool because the word discrete and disconnected both start with D-I-S, so that's a good way to remember that. Discrete functions are disconnected graphs. They're independent variables that we can count. These are things that cannot have a fraction. So if you cannot take a half of whatever you're measuring as your independent variable, it's probably going to show you discrete data. If we were counting months, look at that independent variable there. We would count month 1, 2, 3, and 4. That creates disconnected or discrete data. But if we look at the second graph, its independent variable is age. I don't just turn from 1 to 2 to 3 to 4. I can be 1.5, 2.5, 3.5. That means that this creates not discrete data. It is called continuous data, but we're just going to call it not discrete today. We're looking for graphs that are disconnected. If that line is connected together at all, it is not discrete. Let's talk about some examples of discrete data. So just like counting months, we may also have like ticket sales. If we're talking about the number of tickets I've sold to something, I can't sell half a ticket. That doesn't make any sense. Speaking of things you can't take half of, you can't take half of people. If I'm counting the number of adults or children at an event, I can't count half a child. That's weird. Or cats. I can count cats. Can't count half a cat because that's not a thing. You can count things like suitcases, like the number of suitcases that fit in a trunk of a car. You could talk about jerseys or uniforms ordered for a team because you can't buy half a jersey, or things like the floors of a building. So if you're talking about the number of stories the building has, you can't have half a floor. That doesn't make sense. You either go from floor 1 to floor 2 to floor 3 to floor 4. You don't have half floors. That's not a thing. That's discrete data. Now, one of the things we're going to have to do with this discrete data is talk about the data's domain and range. Now, these vocabulary words of domain and range are going to be something you see over and over and over again. So let's knock it out and let's understand what domain and range are. So domain is defined to be like a description of all of the inputs of a function. So all of the inputs, but sometimes, and most of the time actually, we're going to define this as the set of all x's. And in this little graphic that you see here, it's called Dr. XY Where's Her ID? Dr. XY Where's Her ID? The domain is the x's, and it's your independent variables. So Dr. XY Where's Her ID is going to help us remember all of the pieces that go with domain. Now range is like kind of the opposite. Range is the description of all of the outputs for the graph. So range is the outputs or the set of all y's. And Dr. XY Where's Her ID also helps us with that because range is the y variables, and that's the dependent variable. Dr. XY Where's Her ID? Those are the definitions of domain and range, but in reality, what we need to do with it is be able to describe our discrete functions using its domain and range. These are helpful things to talk about boundaries for our functions. For domain and range, we're going to include these discrete functions in a list. So if I was making a list of the domain of something, I would make a brace, which is a squiggly bracket. You can do this to make your squiggly bracket. Don't do this because that looks like a 3. Technically, the bracket is supposed to be not written like this, not written like this, but written as a bracket. However, if you can only make squiggly lines today, that's fine. But in this squiggly line, all that we're going to do is list the x numbers, no repeats. List the x numbers with no repeats. For the range, I'm also going to use the squiggly bracket to the best of my abilities, and I'm going to list the y numbers Remember, no repeats. It's a list, so we don't have to repeat anything on a list. Just like when you go to the grocery store, you don't have to repeat like oranges on your list twice. Like it's in your list, you're gonna get oranges. Same thing with the domain and range, no repeats. So if we're looking at question number 1, and I'm asking you for the domain and range of this function. For the domain, remember I'm looking for the x's. So all of the x's are here on the x-axis. I'm looking for all of the numbers that I use on that axis. Well, here's where one of the points is at. That's at -3. Here's where another one of the points is at. That's at -1. This guy is at 1, and this guy all the way over here is at 3. That's their place on the graph on the x-axis. So my domain listed from least to greatest is going to be -3, -1, 1, and 3, because those are all the numbers where my domain or my x's show up on the graph. For the range, I'm going to do the same thing, but I'm looking at the up and down or y-axis. So we take those same points and we find their y values. The first point at the bottom, I'm going to go from bottom to top because that's smallest to largest. That's at -2. This one's at 0. This one's at 2. And this one's at 4. So that's the list of numbers from least to greatest with no repeats of all of the y values that this graph uses. Basically, these are the coordinates just organized by x's and y's for domain and range. I want you to pause the video right now, and I want you to try to tell me the domain and range of these 5 points that is represented on this graph. Check it out. How'd you do? A lot of times students on this problem will repeat 2 and 4 in their range because those numbers show up twice. Like there's 2 points that use 4 as their y value. But remember, in my list, I don't need repeats. So my list for range is actually smaller than my list for domain, and that's totally okay. Now, another way we might ask you this sort of question is to tell me the domain and range of a table. But this one's almost easier because if I'm telling you the domain and range of a table, I'm just reading off the x and y values shown in the table. For this function, we have the number of uniforms bought for this team and a total cost. So my domain is going to be the list of all of the numbers of uniforms, which is my inputs that occur in the situation. Bracket 5, 10, 15, 20, 25. No repeats, smallest to largest. And my range is just the y values or the costs of these jerseys. 20, 25, 30, 35, and 40 are the costs that I could have for these jerseys. You guys try number 4. All right, take a second and see if what you wrote down for the domain and range lists for this discrete table matches mine. We know that the number of tickets sold can't sell halves, so this is a discrete data set, and the revenue are shown in the table. Now, if you just straight up wrote down these numbers in this order, you realize that doesn't match how I've written my answer. Can you see why? Why does the order that these are listed in the table not match up with the way that I have written the correct domain? Yeah, these are not in number order. So we actually want our domain to be listed from least to greatest, even if that means I'm writing them in a different order from the way that they're given. That's fine. Same thing with the range. Do you guys notice again that this order that they're written in the table is not the order I put them in the range? These also need to be listed from least to greatest. So again, the order that it's listed in the table doesn't really matter when I'm talking about domain and range. I just need them to be from least to greatest in those lists. Now here's the essential question here. Ms. Quigley, why do we care about this? Great question. So the reason we care about talking about domain and range is it gives us real-world application for our functions. Some functions in real life have boundaries. So like if we are measuring something for time, this time can't start at -5 because that's not in its domain. It doesn't make sense for that graph to be in -5 if I'm dealing with time. So it helps us find the boundaries for our functions. In this problem, it says the function y equals 30 plus 5x represents the cost in dollars of having your dog groomed and buying x extra services. There are 5 extra services that a customer can choose from. And if you're wondering, for this Pampered Pups place, they can get a paw treatment, teeth brushing, nail polish, de-shedding, or ear treatment. Problem A says, describe the number of services a customer can choose. Now, if we're looking at number of services, we already defined that to be X. So if it's asking me to describe the X, I'm asked for the domain. I want to know as a consumer how many extra services I'm being offered when I visit Pampered Pups. Now, the smallest number of extra services that I can choose is 0. I could just decide that my dog gets a regular old bath, doesn't get any extra grooming. She could have 1 extra, 2 extra, 3, 4, 5 extra services because they offer 5. But can I write down 6? No. The graphic and the problem itself said that there are only up to 5 extra services. So my domain is only from 0 to 5 using integers, the list of 0, 1, 2, 3, 4, and 5. As a consumer, I now know what my inputs could be. Part B says, what is the costs that a customer can be charged? Well, if we reread the question, it says the cost is Y. So if I'm asked for Y, y'all, it's asking me for the range. What are the options for me as a consumer for how much money I can spend at Pampered Pups, depending on the number of extra services I use? Now, this is when it comes in handy. We do actually have to use the formula here, or the function, but think of this more realistically than mathy. If I were to get 0 extra services, so there's a 0 for the X. Okay, so right here, instead of X, it's going to say 0. 5 times 0 is 0, and 30 plus 0 is 30, which means it costs $30 for me to get my dog to be groomed. And I didn't buy any extra services. But it looks like when I buy 1 extra service, it's going to cost $5 more. $5 more, $5 more, until I reach the maximum number of extra services that I can get, which is 5. It's $25 extra on top of that 30. And I know now as a consumer that the most I'm going to be spending on my puppy at Pampered Pups is $55 if I give her all the extra grooming services, but the least that I'm going to spend is $30 because it costs $30 just to get her pampered at Pampered Pups. So this is why we care about domain and range. We care because it gives us boundaries in the real world for our functions, and all of the functions that we do mathematically have a domain and range, especially when they take shape of real world problems like going to Pampered Pups. We're going to be practicing domain and range again in class for discrete functions. So remember, these functions are things that I can count, and I list them in their domain and range. Domain is all of the x's, and range is all of the y's. Dr. XY wears her ID. See y'all in class.